Welcome to this predicted paper from onmaths. This paper represents the best guess for the upcoming exams. Please use this paper in addition to your other revision. You can complete a unique version of this paper by going to our onmaths site. Onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions and mini mocks. If you like what we do, please consider subscribing. Enjoy! So we need to first of all understand what a cube number is. So a cube number is the answer to when you get three integers or whole numbers and we multiply them by themselves three times. So 1 times 1 times 1 is 1, 2 times 2 times 2 is 8, 3 times 3 times 3 is 27, 4 times 4 times 4 is 64, and 5 times 5 times 5 is 125. So 1, 8, 27, 64, 125 are all cube numbers, and it goes on forever. And this question's asked us to find all the odd, or an odd, cube number that is smaller than 100. So it has to be odd, so that gets rid of the 8 and the 64. And it has to be smaller than 100, so that gets rid of the 125. So I can either write down 1 would be a fine answer, or 27. I'm going to go for 1. There are 10 squares in total, so each square is worth 1/10. And if we count all of the shaded squares, we notice that in total there are 7 shaded squares. So that's 7 lots of 1/10, or 7/10. So we can draw out our place value grid to help us out with this question. We've got thousands, hundreds, tens and units. So we'll need another one there. So thousands go here, hundreds here, tens here, and then units here. So this says 2000, so a 2 will go in the thousands column, 30, so that'll be a 3 there, and 2. So we need to fill in a 0 here to keep that 2 as 2000, otherwise that would collapse and it'd become 232. So the answer is 2032. Multiples are times tables, so the multiples of 2 are the times table of 2. So 2, 4, 6, 8, 10, 12, etc, etc. So the only number in this list that is in the 2 times table is the 6. To answer this question, we're going to have to remember what BIDMAS or BODMAS is. And it stands for brackets, indices, division, multiplication, addition, subtraction. Okay, if you do BIDMAS, obviously BODMAS is slightly different. And here we've got no brackets, we've got no indices, so those don't really apply. We don't have a division, but we do have a multiplication, so we must do that first. So the first thing we're going to do is we're going to do 8 times 6. 8 times 6 is 48. And we've not got any multiplications anymore, and then we've got an addition. So 11 plus 48 is 59, and that's our answer. Now you wouldn't get the same answer if you did the 11 plus 8 first. That would give you 19, and then 19 times 6 is definitely not 59. To find the fraction of an amount, what we do is we divide by the bottom of the fraction and we times it by the top of the fraction. So the first thing we're going to do is 100 divided by that 5, and that would be 20. Then we're going to get that 20 and we're going to times it by the top of the fraction. So 20 times 4 is 80. So our answer will be 80 centimetres. This question's all about like terms. So what we can do is we can add this 10u with this 11u to make 21u. We can also add this 6v with this plus 4v to make 10v. We can also add this 10w to this minus 6w. So 10 take away 6 is 4w, so plus 4w. But we can't add a u term to a v term to a w term. So we have to just leave them be. So our answer is 21u plus 10v plus 4w. But we can multiply them we just can't add or subtract them. So 55% is the same as 55 over 100. And what I can do is I can divide top one of the fraction by 5. And so that is going to equal 11 over 20. Now in total there are 20 squares here because there's 5 across and 4 down. 5 times 4 is 20. And if there's 20 squares and we're looking to shade in 11 20ths, it's just going to be 11 squares. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. If we write in how many sides each shape has, triangle has 3, quadrilateral 4, pentagon 5, hexagon 6, you'll notice the number of vertices is twice the amount of each of them. So if a shape has 15 sides, we just times that by 2 and it will have 30 vertices. Median just means middle, but it's the middle of the ordered list. So the first thing we need to do is put these numbers in order. So we're going to have 2, 4, 5, 6, 7, and 9. And to find the middle, what we do is we cross off the smallest and the largest, and we put our pen away. Then we do the same thing again, smallest, largest, pen away. Now, you see here that I can't cross out the smallest and largest because that will leave no numbers at all. So when you're left with 2 in the middle, all you need to do is add them together and divide by 2. So 5 plus 6 is 11. And 11 divided by 2 is 5.5. And if you look, 5.5 is exactly halfway between 5 and 6. To find the factors of 30, we're just going to write down all the factor pairs, or all the pairs of numbers that multiply together to make 30. So 1 times 30 is 30. 2 times 15, 3 times 10. Now 4 doesn't go because 30 is not in the 4 times table. 5 times 6, and we notice that if we pick 6, it's just going to be 6 times 5, it's just going to be the opposite. So the factors are all the numbers that we've just written down, so it would be 1, 2, 3, 5, 6, 10, 15 and 30. To find a coordinate, what we can do is we can start in the middle and we work out how far across we have to go. And here we have to go 2 across, so the x coordinate is 2. Then we find out how far upwards or downwards we have to go. And here we can go, well, we have to go 3 downwards, so that's going to be -3. So we first of all look at the x coordinate, the 2, then the y coordinate, -3, along the corridor, up, or in this case down the stairs. So we're just going to start by writing the number a little bit bigger. So it says 2 decimal places, so we're going to draw a line after the second decimal place. Now all the numbers to the right are going to disappear, they're going to turn to 0, and because it's a decimal that just means we get rid of them. But we have to look at this number first. Now if this number is less than 5, we just keep the number to the left, so 8.17. But if it's 5 or more, then this 7 goes up to an 8. So this will be 8.18. To be able to add or subtract fractions, we must make the denominators the same. So what we do is we write out the 5 and 7 times tables. So 5, 10, 15, 20, 25, 30, 35. And you keep going through each times table until you get to a number that's the same in both. You can see it's 35 here. So we're going to times top and bottom by something to make the denominator 35. So for this first one, it's going to be 7. So we're going to times top and bottom by 7. For the second one, it's going to be 5. So 2 times 7 is 14, and then the bottom will be 35, the denominator. and then 2 times 5 is 10, and the denominator will be 35. Then when we have that, we take away the numerators. So 14 take away 10 is 4, and that just leaves 4 over 35. So we can see whether we can cancel it, and we can't. So the answer is just 4 over 35. To multiply fractions, all you need to do is multiply the tops. 3 times 7 is 21, and multiply the bottoms. 4 times 11 is 44. We see whether we can simplify this, but actually there's no number that goes into 21 and 44, so it's 21 over 44 is our answer. So what we do is we notice that to get this 10, we add the 3 and the 7. To get this 17, we add the 7 and the 10. And to get this 27, we add the 10 and the 17. Whenever we have this kind of sequence, it's called a Fibonacci sequence. You essentially add the previous two terms to get to the next term. And so what we need to do is just simply add the 17 and the 27. When you do that, you get 44. So our next term is 44. So the first thing we're going to do is write this as a ratio between the fractions. So we're going to have green to black. Now it says that a quarter of the counters are black, and therefore the remaining counters will be green. So if a quarter are black, that leaves 3/4 to be green. And what we can do here is on both sides of the ratio, what I'm going to do is just times it by 4. So I'm just going to times 4 both sides. So 3 divided by 4 times 4, because over 4 just means divided by 4. So 3 divided by 4 times by 4 just gets rid of the fraction. And 1 divided by 4 times 4 is just going to be 1. Now this might surprise some people because they will probably think it's a ratio of 4 to 1. But we can show here that it's a ratio of 3 to 1. For each of these options, try and construct in your head the triangles that would be made from these lengths. And I'm going to give an example for question D, or for option D. And I'm going to construct my triangle just with sticks. So we're going to start off with our first stick, which is 19 centimeters. Then we're going to do another stick, which is going to be 37 centimeters. And we've got one last stick, which is 61 centimeters. Now, looking at the first two sticks, the actual combined distance of them, so when we add them together, so be 19 centimeters plus 37 centimeters, is 56 centimeters. So that's the combined width of them. And you can see that that actually wouldn't be able to create a triangle if the third stick is 61 centimeters. So the side here could combine with this side. So we could move this whole stick here onto this side here, but we can't actually make a triangle with it because the two lengths that we've got won't ever reach the end bit here. They just won't ever reach that bit to be able to create the triangle. And I'm just going to put that back. So our answer is option D. So the pass mark for the test is here, and we can see that there are 2 students who passed the test. So it's 2 students out of 2, 3, 4, 5, 6, 7 in total. And we want this as a percentage, so we're going to times it by 100%. So we do 2 over 7 times 100, and that gives us 28.571 blah blah blah. And it says it wants it to the nearest percent, so that will be 29%. When simplifying ratios, we're looking at doing exactly the same thing as when you simplify a fraction, but instead of top and bottom, we're looking at left and right. So we've got to do the same thing to the left and right. So here we've got 12 and 45. Well, I can divide both of those by 3. They're both in the 3 times table. 12 divided by 3 is 4. and 45 divided by 3 is 15. So our simplified ratio is 4 to 15 because I can't go any further. So we've got to first of all work out how many parts there are altogether. So we're told that the ratio of red, yellow and green is 3 to 2 to 4. So to work out how many parts there are altogether, we do 3 plus 2 plus 4, which is 9 parts. So there's 9 equal piles of sweets. Okay, but to work out what one part or one pile of sweets is worth, we're going to get the 99 sweets and divide it by the amount of piles, and that's going to be 11. So one part is worth 11 sweets. We're asked to find out how many yellow sweets, and yellow is the middle one, so it's going to be the 2. So yellow has 2 piles of 11 sweets. 2 times 11 is going to be 22, so it's going to be 22 sweets. To get from the length of a square to the area, we square the length. To work backwards, what we do is we square root, because the inverse of square is square root. So we've got 196 and we're going to square root it to find the length. So we work out the square root of 196, which is what number times itself is 196. And you should learn them from 1 to 15, so you should know all of the square numbers from 1 to 15. So you should know that the answer is 14. So the length therefore is 14. So to work out what the perimeter is going to be the distance around the square. So if I draw a square out, we know that each of these lengths are 14. So it's just going to be 14 times 4, which will be 56. The median is the middle number when the numbers are in order. Now it's quite difficult to do with a table, so we used a formula, and that formula is to find the position of the median. We do how many numbers there are, which I'll call n, we add 1 to it, and then we divide that by 2. And that shows us where the median is. It doesn't tell us what the median is, it shows us where it is. Now, we need to figure out where these numbers are in this list. So the first number is a 2, and there is 1 of those. The next number is a 3, and there's 3 of those. So 1, 2, 3. The next number is a 4, and there's 4 of those. So 1, 2, 3, 4. The next number is a 5, and there's 8 of those. So 1, 2, 3, 4, 5, 6, 7, 8. And the next number is a 6, and there's 13 of those. Now I'm not going to do all of them, okay, because we're not going to be working out the median by writing out all the numbers, but I do want to show you where these numbers are coming from. So what we do is we do a running total. So I'm going to do a running total. The running total is just adding up the frequencies as we go. So the first one is just 1. Then we're going to add the 3 in the next row, so that's 4. Add the 4 in the next row, 8. Add the 8 in the next row, 16. Add the 13 in the next row, and that would be 29. Now, we use the running total because the running total shows us where the last number is in that group. Okay, so this shows us that the first number is the last number that is a 2, which is true, we can see it here. This 4 shows us that the fourth number is the last number that's a 3, so let's check that. 1, 2, 3, 4, it works. This 8 shows us the 8th number is the last number that's a 4, let's check that. So 4, 5, 6, 7, 8. This 16 shows us the 16th number is the last number that's a 5. So 9, 10, 11, 12, 13, 14, 15, 16. And this 29 here shows us that the 29th number is just the last number, but it's the last number that's a 6th. Okay, so let's work out how many numbers there are, and we do that by adding up the frequency. So we're just going to add up all of the frequency together, and we find out that there's 29 numbers altogether. So 1 plus 3 plus 4 plus 8 plus 13. So using our formula, which is 29 plus 1 divided by 2, 29 plus 1 is 30, divided by 2 is 15. So we're looking for the 15th number. So looking down our running total list, well, the last number that's a 4 is the 8th number, so we haven't got to the 15th number yet. And the last number that's a 5 is the 16th number. So if the last number that's a 5 is the 16th number, then surely the 15th must also be a 5. And so our median is 5. The front elevation of a shape is the view you'll get if you were standing at the front. So if you imagine you're standing here, the only side you will see is this side here. And what will it look like? Well, it will look like a complete square or rectangle. And how high will it be? Well, it will be 6 centimeters high. And how wide will it be? Well, it will be 2 centimeters wide. So what we're going to do is we're going to just draw a rectangle that is 2 centimeters wide and 1, 2, 3, 4, 5, 6 centimeters tall. There we go. And make sure that you don't add any three-dimensional aspects to it, that you don't do something like this, have some 3D stuff on it. No. Whenever you do a front elevation, it's exactly perfectly two-dimensional. So x can be any number that is where the line is. So if I show, x can be anywhere along here. Okay. And so what we're going to do is we're going to write that x can be anything that's greater than -9. Okay, so it could be -8, it could be 0, it could be 100, but it can't be -10. Now, it's a filled in dot, so x can actually be -9 as well. So we've got to first of all work out how many parts there are altogether. So oil has 21 parts, vinegar has 5, so altogether there's 21 plus 5, which is 26 parts. Now, how many of those parts are vinegar? Well, vinegar is the second one, so it's going to be this 5. So vinegar has 5 out of the 26 parts, or a fraction would be 5 over 26. I'm going to start by working out what the building is, or the width of the building is in centimetres. So it says 33 metres, and I'm going to convert that into centimetres by timesing by 100. Okay, now when it says it has a scale of 1 to 300, it means 300 in real life is 1 on our map. So all I need to do is divide it by 300 to find out what it's going to be on our map. So we'll just divide that by 300 and I get the answer of 11. So it's going to be 11 centimetres on our map. All probabilities have to add up to 1. And so the probability it will rain tomorrow is 0.15. And so the probability it won't rain is 1 minus 0.15, which will be 0.85. The experimental probability is the successful outcomes divided by the total number of outcomes. So we're looking for the probability that it's white, so it's going to be 25 over, and we're just going to do 35 plus 25 plus 31, which is 91, and that's our probability, 25 over 91. Be careful when it say total, you must include all of the outcomes, so red, white, and other. A sample space diagram is basically a diagram that shows all the outcomes, and we've got the outcomes from spinner 2 at the top, so either 1, 2, or 3, and we've got the outcomes from spinner 1 down the side, so A, B, C, D, or E. And we're just writing down all the combinations. So this will be A2, A3, and then this will be B1, C1, D1, E1, and this will be B2, C2, D2, E2, and this will be B3, C3, D3, and E3. And this represents all the possible outcomes you can get from both spinners. So if we imagine we've got the 25 meter pipe here, and we've got the 35 meter pipe here. The question's basically asking us what can we cut all these pipes into, and they all have to be the same length that will fit with the 25 meter and the 35 meter. And essentially what this question is asking is, what is the highest common factor of 25 and 35? So to find the highest common factor, what we do is we just find the factors of 25, which is 1 and 25 and 5 and 5, and the factors of 35, which will be 1 and 35 and 5 and 7. And the highest common factor is the number in both lists, the highest number in both lists, so it's 5. So what we can do is we can cut all of these pipes into 5 meter pipes. So 1, 2, 3, 4, not to scale, and then 7 of these, so 1, 2, 4, 5, 6, and so there's 7 in total. So each of these are 5 meter long, and there's no wastage, and that's the longest we can make the pipes for there to be no wastage at all. So my answer is 5 meters. So to do this question, you just need a piece of paper, a ruler and a protractor. And the first thing we do is we draw the 11 centimeter line. And my one will not be 11 centimeters for you. It is on my screen, but because depending on what device you watch this on will change obviously its length. And what I'm going to do is I'm going to put my protractor on this end here. So I've kind of got my protractor here. And I'm going to just have a look at getting 39 degrees. Now you've got to be careful because 39 is on the inside, and I'm just going to do a dot. So always look to see which one, the inside or the outside of the protractor, starts at 0. And the inside should start at 0 from this side. And I'm just going to draw a line that connects the end of that line and the dot. Like so. Now just you can keep it going. Right, the next thing I'm going to do is put my protractor on the other side. So my protractor is kind of here. And I'm lining up the crosshairs with this point here. But this time I'm measuring on the left hand side, and I'm looking at 59 degrees, which will be here. Get my ruler. Now this time I can actually stop where it hits the other line. So keep going and then stop where it hits the other line. And this screen's not perfectly calibrated, so it's difficult to do precise work, something like that. And then what you can do is you can get your rubber and just rub out the extra bit of line that we had to do. And so this is our 39 degrees here. And you don't need to label this on the diagram, but just so we know what we're doing. And it says when it's completed, measure length x. So I'm going to get my ruler out and I'm going to measure this length here, this one here. And it is about 95 millimeters. So the answer for me is 95 millimeters. Now there is some level of precision. You're not going to get necessarily exactly 95 millimeters. When we mark these questions, we normally have an overlay and we put it over the top, and if it's roughly the same, and you can make small errors because nobody's perfect, and my diagram definitely is not perfect, but there are allowable small errors here and there. So I'm going to start just by writing out the equation, and I can put my lines in. Okay, we're asked to make x the subject, so we're going to first of all add 10 to both sides. In fact, I'm just going to move all this over a little bit so I've got a bit more space. Okay, so we're left with m plus 10 on the left hand side, and we've got 1/7 x on the right hand side. Now to get rid of the 1/7, what I can do is just times both sides by 7. So 7 brackets m plus 10 equals x. So x therefore would equal 7 brackets m plus 10, but it says expand your answer fully, so we're just going to expand the brackets. 7m plus 70. So here we're asked to find how many bread rolls we can make. We've got 89 kilograms and it takes 0.08 kilograms to make a bread roll. Something we can do is convert these into grams, or we can just keep it at kilograms, but I've got a neat little trick. And the trick is, if you've got a decimal when you're dividing, as long as you do the same thing left and right, you can multiply them by 10 or 100. In this case, we're going to multiply both by 100, because it will make the division a lot easier, because it will make this right hand side, instead of 0.08, it will just make it 8. The reason we can do that is 89 divided by is the same as 89 over 0.08, and as a fraction we can just times top and bottom by 100, so it would be this over 8. So now we can do the bus stop method. So 8 on the outside, and in fact I might use a straighter line here. There we are. And we've got 8,900 on the inside. So 8 into 8 go 1, 8 into 9 go 1, remainder 1, 8 into 10 go 2, remainder 2, and 8 into 20 go 2, remainder 4, and 8 into 40 go 5. Now it says how many bread rolls can we make. Now we can make 1,122 and a half. Well, half doesn't really count, so we're just going to say 1,122 whole bread rolls. Yes, we've got half a bread roll left over, but we are asked how many whole bread rolls can we make. To find out what the value of x is, we first of all have to find out what the value of y is. And we can notice that we've got two sets of parallel lines here, and a line going through them. And we kind of got these F angles, which we have to call corresponding angles. So we know that 2y minus 50 is equal to 78. And we must write down the reason. So corresponding angles. And corresponding angles are equal. Now here we've got an equation and we want to solve it, so we get our lines in. We go first of all add 50 to both sides. So we've got 2y equals 78 plus 50, which would be 128. And then we're going to halve both sides, or divide by 2. So we've got 64. So we know that y is 64. And so we look back at the diagram to find out how we'd work out x. Well, what we can do, there's a few different things we can do. We could work out the fact that these two here are vertically opposite. That would be absolutely fine. But actually, if we look at this part here and this part here, these are also two parallel lines, and we've got this angle here and this angle are going to be alternate. So I can write that down here. So angle ECB is equal to 78 degrees. So this will be 78 degrees. And the reason for that is alternate angles. And then finally, if we know this is 78 and we know that this is 64, because we know what y is, then we can work out what x is. So x equals 180, angles in a triangle, take away the 78 we know and the 64 we know. And the reason for that is angles in a triangle add up to 180 degrees. And just make sure you write down all the reasons as you go. And when we take away the 78 and the 64 from 180, you get 38. So x is therefore 38 degrees. On a scatter graph, an outlier is a point which doesn't fit the pattern. And as we can see here, all of these coordinates fit kind of a nice line going down there. So they all are showing a trend. But we've got this point here that's nowhere near that trend at all, and that's what we call an outlier. So we know that these are going up in twos, so this will be 28, so the x-coordinate will be 28, and this will be 19. So our coordinate will be 28, 19 for our outlier. We're going to start by looking at the numerator and the denominator separately. So looking at the numerator first, we've got 9 to the power of 16 times 9 to the power of 46. Now, when you have two powers of the same base, so they're both 9, base 9, but base is the big number, then what you can do is you can add the indices. So we're going to do 16 plus 46, which is 62, so it's 9 to the power of 62. And looking at the denominator, well, you've got a power inside and outside the bracket. Whenever you have that, you can just multiply them. So it'd be 9 to the power of 40. Now, whenever you've got a division between two powers of the same base, which we have here, it's 9 to the power of 62 divided by 9 to the power of 40, we just take away the indices. So it'd be 62, take away 40, which will be 9 to the power of 22. So our answer is 9 to the power of 22. So for this question, we need to understand the different types of graphs from different functions. So if we have a reciprocal graph, it looks something like this and like this. It could be the other way around, and it could be distorted, but it basically goes down to a point along here. It goes to infinity, and it goes to infinity along a point over here, and obviously those positions could change. Then we've got a linear graph. A linear graph is just any straight line, so just any kind of straight line, either up or down, and this doesn't look like either of those. Then we've got a exponential graph. An exponential graph just starts really small and then just really increases like that and just keeps going up. And here we kind of have that, obviously the other way around, it starts going down, but here it's actually going up, so it can't be a reciprocal graph. So the graph that this is, or could be, is a quadratic graph, because it's a nice U shape, so if we carry this on, it could be a nice U shape. It could also be a cubic graph as well, so it could go up and then down and then up, and that's a cubic graph. But the most obvious one is a quadratic graph. So quadratic function. There is quite an easy way of doing this question, but I'm going to show you the long way, and then we're going to work out what the quicker way is. So I'm going to pair up the a and the 1, which it suggests in the question. Then I'm going to work out the a and the 2 as a different combination, a3, a4, etc. Then I'm going to look at the b and do the same thing, b1, b2, b3, etc. Then I'm going to work out the c, so all the combinations with c. So how many combinations are there with a? Well, there's going to be 7 because there's 7 numbers. How many with b? Well, there's also going to be 7. And how many with c? Well, there's also going to be 7. So in total, there's going to be 7 plus 7 plus 7, which is 21. And the way I can work that out easily is work out how many combinations there are with spinner 1. Well, there's 3. How many combinations there are with spinner 2? 7. And we just times the 2 together. 3 times 7 is 21. So angles on a point add up to 360. And we are given the values of the angles, but in terms of r. So we know that r plus 9r plus 20 will equal 360. So we've got an equation here we can solve. So first of all, let's add the r's together. And so that will be 10r plus 20 equals 360. Then we're going to subtract the 20 from both sides. So we have 10r equals 340. And then we're going to divide by 10 both sides. So we have r equals 34. So our answer is 34. There's a lot going on with this question, so what I'm going to do is I'm going to put in all of the time signs that we don't normally show. So we've got 10 times 12x times y to the power 4 times 13 times x to the power 4 times y to the power 4. And I'm going to reorder these to put the numbers together, first of all. And with multiplying, it doesn't matter which way around you do it, so I'm not changing anything. I'm going to put the x's together. And I'm going to put the y's together. So, first thing to do is 9 times 13, which is just 117. Then we've got x to the power of 12 times x to the power of 4. Now we know when we multiply two powers of the same base, and the base is x on both of those, we just add the powers. So it's 12 plus 4, which is 16. So it'll be x to the power of 16. And then y to the power of 4 times y to the power of 4, we just add them together, so it's y to the power of 8. So the way this formula works is we have m, which is the final amount. The 2000 here is our initial amount. The decimal in here is our multiplier, and the power here is the amount of years. So the way multipliers work is they are the percentage divided by 100. So if we go the other way and times it by 100 to make it back into a percentage, it will be 102.9%. Now it says, what is the interest rate of the bank? Well, the interest rate is always going to be 100%. Well, this 102.9% is 100% plus the interest rate, which will equal the 102.9%. So the interest rate is going to be the 2.9%. You always start off with 100%. So if I put £5 into my bank, I've got 100% of that £5, and then the interest rate is on top of that 100%. So our answer here will be 2.9%. In this question we have a right angle triangle, and we know two of the sides and we're looking for the third one. So that screams to me Pythagoras. So Pythagoras is a squared plus b squared equals c squared, with c squared being the hypotenuse. The hypotenuse is the one opposite the right angle, so this is going to be c. And we'll label the other ones a and b, it doesn't matter which way around they go. So a is 5, so it'll be 5 squared plus 12 squared equals c squared. 5 squared is 25, 12 squared is 144. And so 25 plus 144 is 169. Now that's c squared, so we need to solve here, and the way to solve is just to square root both sides. And so it would be 13 equals c. Because it's distance, we don't worry about the negative 13, so just the positive 13. So we know c is 13, so we need to know what the total length around the triangle is. So we're going to add the 5, the 12 and the 13 we've just found. When you do that you get 30. So we know there's 30 meters in total. Now it does say that we need 90 milliliters of paint per meter of wood. So the amount of paint needed is going to be the 30, because that's the total distance, times the 90, because we need 90 for every meter of paint. 3 times 9 is 27, and then put the 2 zeros at the end. So the answer is 2,700 milliliters. So we need to first of all work out how many black and red counters there are at the start. Now if you look at the fraction of the probability of picking a black, in your first pick is 2 over 5, and then the second pick is 1 over 4. So you can see that there's one less at the numerator and then one less overall. So that means we can conclude that there are 2 blacks at the start, 2 black counters, and if there are 2 black counters and there's only black and red counters, then there must be 3 red counters, so that to make up the fact that it's 2 over 5. Okay, so to find the missing probabilities, the first couple are quite simple, because we know that, let's do a different colour, this and this have to add up to 1, And so if the probability of picking a black there is 1/4, then the probability of picking a red must be 3/4, because these have to add up to 1. Same with these two, these have to add up to 1. So if we've got 2/5 at the top, the bottom one must be 3/5. And finally, we've got these two here. Now these two here we're not given any fractions for, but given the fact that we started with 2 black and 3 red, we've picked one of the red, so we've got one less red, and that means we've got 2 black counters and 2 red counters. So it means that the probability of picking a black is 2/4 or 1/2, and the probability of picking a red is 2/4 or 1/2. Something we know about rectangles is opposite sides are equal. So these two will be equal. And these two will be equal. And you notice now that we've got simultaneous equations. So what I'm going to do is get the coefficient of the y the same. And I'm going to do that by multiplying everything in the second equation by 3. So we get 6x plus 9y equals 123. And I'm just going to write in the first equation underneath, because with simultaneous equations we work downwards. Now looking at the signs, they are the same, and the s in same is the s in subtract. So we're going to subtract going downwards. We're just going to subtract going downwards. So 6x take away 3x is 3x. 9y take away 9y is nothing, which is good. That's what we need. And then 123 take away 93 is 30. We're going to get our solving lines in, and we're just going to divide by 3 both sides. So we've got x equals 10. So we know what x is, but we need to find out what y is. So what I'm going to do is I'm just going to pick one of the equations. I can pick the 2x plus 3y equals 41, and just substitute the value of x in. So 2 times, instead of x, it's times 10, plus 3y equals 41. So it would be 20 plus 3y equals 41. Get my solving lines in. And we're going to take away 20 both sides. So we've got 3y equals 21. And then we're going to divide by 3 both sides, if I don't run out of room. So y equals 7. So we've got x equals 10, y equals 7. Now I could check that with the first equation as well. So 3 times 10 is 30, 9 times 7 is 63, 30 plus 63 is 93. So we know we've got it right. So we're going to first of all realise that this is a right angle triangle, and we've got 2 lengths and an angle involved, therefore it's going to be trigonometry. So we're going to just label the sides first. The one opposite right angle is the hypotenuse, opposite the marked angle is the opposite, and the one between the right angle and the marked angle is the adjacent. Now the adjacent doesn't have a number or a letter next to it, so it's not interesting, so get rid of that. Next we're going to do our trigonometry triangles. And so we've got SO, Ka, Toa. And we are just crossed out the adjacent, so we don't need this one and we don't need this one. And we're going to end up with SO, which is short for sine the angle equals opposite over hypotenuse. The angle is marked as x, so sine x equals √3 over 2. You need to know from memory that sine 60 is √3 over 2. And notice here that the x therefore is going to equal 60. With this question you've just got to know what the different functions look like. So with C and D we've got quadratic functions. One's a positive quadratic, which is a U shape. One's a negative quadratic, which is a kind of upside down U shape or an N shape. And here we don't have that, so we can get rid of those in our thoughts straight away. A is a positive cubic, which goes up, then down, then up again. And B is a negative cubic, which goes down, up, and then down again. So this one here goes up, down, up again. That's going to be a positive cubic. So our answer is A. You can complete a unique version of this paper by going to our onmaths site. onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions and mini mocks. If you like what we do, please consider subscribing.